Have you ever wondered why you feel lighter on the moon but your body doesn't actually change? Today, we're diving into the fascinating world of weight and gravity. Many people use the terms mass and weight interchangeably, but they're not the same thing. Understanding the difference is key to grasping how gravity affects us, whether we're on Earth, the moon, or floating in space. Let's break down these concepts and see how they shape our everyday experiences, from standing on a scale to watching astronauts float in orbit. First, let's talk about mass. Mass is the amount of matter in an object. It's a fundamental property that doesn't change no matter where you are in the universe. Whether you're on Earth, the moon, or Mars, your mass stays the same. Think of mass as the stuff that makes up you or any object. It's measured in kilograms kg and is a scalar quantity, meaning it only has magnitude, not direction. This is why your mass is always constant, regardless of your location. Now let's look at weight. Weight is the force that gravity exerts on your mass. Unlike mass, weight can change depending on where you are. It's measured in newtons n and is a vector quantity, which means it has both magnitude and direction, always pointing toward the center of the planet or moon you're on. Your weight is what you feel when you stand on a scale, and it's why you feel lighter or heavier in different places. Relationship between mass and weight is captured in a simple formula. Weight equals mass times gravity, or W equals mg. Here, W stands for weight for mass and g for the acceleration due to gravity. This formula helps us calculate how much force gravity is pulling on an object, whether it's a person, a rock, or a spaceship. The value of g changes depending on where you are in the universe. On Earth, the acceleration due to gravity is about 9.8 meters per second squared, ms2. This means that for every kilogram of mass, gravity pulls with a force of 9.8 newtons. So if you have a mass of 60 kilograms, your weight on Earth would be 60 times 9.8, which equals 588 newtons. This is the force you feel pressing you down onto the ground. What happens if you travel to the moon? The moon's gravity is only about 1/6 that of Earth, roughly 1.63 ms2. Using the same mass of 60 kilograms, your weight on the moon would be 60 times 1.63, which is about 98 newtons. That's much less than on Earth, which is why astronauts can hop and float so easily on the lunar surface. Even though your weight changes depending on gravity, your mass remains the same. Whether you're on Earth, the moon, or floating in space, you still have 60 kilograms of mass if that's what you started with. This is why astronauts, despite floating in space, still need to eat and maintain their bodies. They haven't lost any mass, just the force pulling them down. Let's recap the key differences. Mass is a fundamental property. It's the amount of matter in an object and doesn't change with location. Weight, on the other hand, is derived from mass and gravity, and it changes depending on where you are. Mass is measured in kilograms and is scalar, while weight is measured in newtons and is a vector. These differences are crucial for understanding how objects behave in different environments. Another important distinction is that mass is a scalar quantity, meaning it only has size or magnitude. Weight, however, is a vector. It has both magnitude and direction. The direction of weight is always toward the center of the planet or moon you're on. This is why weight can be represented with an arrow in diagrams, showing both how much and which way the force acts. How do we measure mass and weight? Mass is measured using a balance which compares an object to known masses. Weight, on the other hand, is measured with a spring balance which stretches in response to the force of gravity. The difference in measurement tools highlights the difference between these two concepts and why it's important not to confuse them. Units matter. Mass is always measured in kilograms kg, while weight is measured in newtons n. This difference in units is another clue that these are not the same thing. When you see a number in kilograms, you're talking about mass. When you see newtons, you're talking about the force of gravity acting on that mass. Spring balances are fascinating tools that work based on Hooke's law. This law states that the stretch of a spring is directly proportional to the force applied to it, in this case your weight. The heavier the object, the more the spring stretches. This is why spring balances are perfect for measuring weight but not mass. In space, astronauts appear to float because they're in free fall, experiencing very little gravity. Their weight is almost zero, but their mass remains unchanged. This is why they still need to eat, exercise, and take care of their bodies. The lack of weight doesn't mean a lack of mass, it just means gravity isn't pulling them down as strongly. Ever wondered how massive ships can float on water? It's all about gravity and buoyancy. The ship's weight is balanced by the upward force of the water, allowing it to float. This principle works because gravity acts on the ship's mass, but the water pushes back with an equal force. Understanding weight and gravity helps explain this everyday marvel. Sum up, mass and weight are closely related but fundamentally different. Mass is the amount of matter you have and it never changes. Weight is the force of gravity acting on that mass and it changes depending on where you are. Understanding this difference helps us make sense of everything from floating astronauts to ships at sea. Gravity's pull shapes our world in ways we often take for granted.